Let's look at this quickly. This is a problem under kinetic energy. A body of mass 8 kg at rest is acted upon by a constant force of 16 Newton for 4 seconds. Calculate the kinetic energy gained by the body. Quickly, as usual, we'll write down the parameters. Mass is given as 8 kg. At rest, U is 0. Constant force of 16 Newton. Time is 4 seconds. These are the parameters given. So we are asked to calculate kinetic energy. I will know the formula for kinetic energy is half mv squared. We know m, but v is given indirectly. So we appeal to this equation of motion to calculate v. So in this case, v will now be equal to 0 because u is 0 because the body was stationary, plus, okay, let's look at the acceleration first. Know that F is equal to ma. Force is given. Our force is 16 equal to mass is given as 8 times A. So A now will be equal to 16 by 8, which will give us 2 meters per second square. So we can now appeal to this equation to calculate V. V in this case will be equal to 0 because U is 0 plus A, we just calculated to be 2 times 4. And V will be equal to 8 meters per second. So we can now deploy this formula. Therefore, kinetic energy is equal to half times the mass is 8 kg times the velocity, which is 8 squared. So if you multiply this out, you now have kinetic energy to be equal to half times 8 times 64. So these two can take care of this. 2 here, 1, 2 here, 4. So we have kinetic energy to be equal to 4 times 64, which will give us 256 joules. Alternatively, kinetic energy is equal to work done. Kinetic energy is equal to work done. And, or we can say that kinetic energy is equal to work done, which is equal to force times distance. But in this case, we don't know what is distance. So we can use the equation of motion. S is equal to ut plus half at squared to calculate the distance. S now will be equal to 0 times t is 4 plus half times 2 times 4. This is 80 squared. So this will be squared. So we now have S to be equal to, the whole of this becomes 0, half times 2 times 16. So we can say that this can take care of this, and S will be equal to 16 meters. So if you deploy this formula, if you now say S, kinetic energy now will be equal to work done, which is equal to 16. The force is given as 16 times the distance as 16, and that will give us 256 joules, which is the same thing as this.